Good afternoon, everyone. With our invocation now, it's Dottie Hildebrand, who is going to be coming to us via the miracle of technology.
Yes, and I'm so grateful. I plan to be with you guys in person today. But yesterday I was exposed to COVID, so I'm self-quarantining in an attempt to manage any potential spread. So sorry I can't be there with you. But on that being said, I'm kind of on the same thread as John is in that I'd like to talk about gratitude. I think gratitude helps us reframe our thinking. It lifts us up, giving a new perspective out of what we are currently in the midst of. I'd like to share a recent experience I had with gratitude as it also pertains to our guest speaker's topic of immunotherapy. Earlier this year, my husband and I received the tough news that his mother was diagnosed with metastatic cancer. I attend some of her appointments with her as an extra set of listening ears. And when on one of those appointments, we learned the encouraging news about immunotherapy, my response was gratitude. I'm grateful for the research work that has been done and is being done, and grateful for the scientists and doctors that have persevered for these medical breakthroughs, greatly improving our quality of life and hope for a future with her. Gratitude gave me a new perspective. I invite you to join me in prayer, please. Lord, cancer has touched every person in this room. It seems to know no bounds. I pray for your provision for each one of us, provision of comfort, provision of good medical care, and your healing hand. We're grateful for the good news of medical breakthroughs like immunotherapy. Thank you for those who are making a difference in the quality of life. In the name of Jesus, amen.
Amen. Thank you, Dottie.
You're welcome.
Guests today, if you have a guest at your table, if you just shout out, we'll just recognize them all in one group. Anyone with a guest? Hey. All right, great. Welcome. And remember that membership applications are always available. So please join. 2 weeks from Saturday, we will be joining Sunrise Rotary and Southwest Rotary and the city of Yakima on a small, well, it's not a small project, it's actually a big project, but our part's pretty small. It's a neighborhood cleanup day, and Sunrise, Southwest, and our club has taken on a 3-block area near Yakima Valley College. And so we are looking for a few good men or women. It won't take very long. It's probably going to be less than an hour on the morning of Saturday, September 18th. So if any of you have some time and would like to do that, either let me know or let the office know, and I'll coordinate you and get you the time and everything. As I said, it's not going to take a long time. It's just a matter of going around the neighborhood and picking up trash and whatnot in the public areas. Second announcement is Fair Day. I mentioned this last week. Normally we have a meeting out there, but the name of the game these days is flexibility, and that much often overused word right now, pivoting. So we are still going to have the opportunity to go to the fair, but we're not going to actually meet in that state fair room this year because there's a little more restrictions and whatnot, and being in that close quarters and whatnot. So if you'd like to go to the fair, we are providing the tickets and parking. The fair is doing it at a reduced rate. There will be a sign up through the email and through here, and you'll be able to go on your own. There won't be a meeting that day, and instead you can use the time to help support the fair. This has been a long time tradition. I think, as most of you know, the first fair was in 1894, and I was not there. I'm not sure anybody here was, but it has been going pretty much continuously. It's been canceled only twice in its history, once in 1924 for hoof and mouth disease, and last year for something else we might know something about. One piece of sad news, if you've not already heard it, both Bob and Harriet Redmond have passed away within the last week and a half. There will be a joint service for them at St. Timothy's Church at 1:30 on Saturday, September 18th. Again, Saturday, September 18th. Memorials, they would like to go to the Yakima Rotary Trust If anybody would like to do that, please do that in their memory. And I'm also to announce that masks will be required at the church. So with that, we have a few programs and whatnot coming up. First, Sherry Bissell and members, which are always ultimately important.
Thank you, President John. So membership, we are planning. You are going to get very, very tired of us talking about it. So one way to not get tired of us talking about it is to bring potential members. And then you'll probably stop hearing from us. It's myself and Austin Beebe who are chairing membership this year. We have an awesome committee. To those of you who are on our committee, by the way, we will be meeting. We'll get you together. We need your ideas. Austin and I are doing some quick planning. We will need your help, so stay tuned for that. Will this year be a challenge? Yes. Was last year a challenge? Yes. This year won't be as much of a challenge. And you guys are awesome. So I don't think we're going to have any problem. We just need you to bring potential members and we'll grow the club. Easy, right? Right. Okay. So this is how we're going to do this. First, I need you to mark your calendars for our very first R&R membership recruiting event. R&R, rest and relaxation, you say, right? No. No. It is refreshments with Rotary, R&R. Refreshments with Rotary and Rover 2. Rover's a dog, just in case you didn't know that, because we'll be meeting on Wednesday evening, October 6th from 5 to 7 at the Kiln. And as most of you know, if you have dogs or if you are a dog lover, a lot of these places allow you to bring your dogs. So it's R&R and R, refreshments with Rotary and Rover 2. Got it? Okay. That will be Wednesday, October 6th, 5 to 7. We will have more information about that. There will be prizes. Okay. There will be prizes for prospective members that come and the Rotarians that bring them. You have to stay tuned for that because we will work on that. Austin and I are working on actually some fabulous prizes. And so stay tuned for that. What else? Oh, last. Next Thursday, in case you didn't know, and you didn't know because we haven't told you yet, next Thursday is Bring an Industry Colleague to Rotary Day. It's a really good thing I wrote that down because I almost lost that. Bring an industry colleague. What does that mean? That doesn't mean bringing somebody, at your place of work. It means bringing somebody that you work with, like a client or somebody in your industry or someone like that. Again, prospective member. That's what next Thursday is. Okay. So let's do that. How many of you have already brought a prospective member to Rotary this year? Okay. For that, you get this. Oh, wait, hold please.
Duh, winning.
Did you hear that? Duh, winning. Okay. What you don't want to hear is this.
You are one pathetic loser.
You don't want to hear that. Okay. So next Thursday, bring an industry colleague to Rotary Day. Okay. And you'll hear either myself again. Sorry, but if you bring more, then you won't hear me as much. Or Austin up here, and we'll be talking about it again. So stay tuned. Thank you very much.
Thank you, Sherry. And please give her, Sherry and Austin and the whole committee a hand. This is really important to keep our club up and growing. We've been here for 102 years now and want to be here for another 102. So, and with that, Charlie.
A quick note on the music committee. While this year, under my leadership, it was intended that the entire Rotary would become an 8-member community chorus. We are mindful of COVID and we'll take a break from that. So just so you know, we are going to be honoring your requests. We will not have group singing. We will have soloists and videos. So for music, just be aware, we are honoring your requests and your concerns in that regard. So thank you very much for those of you who did comment. For the scholarship dinner, this is your last chance. Yakima, who chooses to do things last minute, this is the last minute. On the tables in front of you are the yellow sheets. If you've not yet filled one out, please fill that information out. If, when you receive your information, you realize that, oops, I said something wrong, oops, I'm no longer comfortable doing that, contact me and or contact the Rotary office directly. We will manage that for you right away, but we have to have all that immediately. So please do communicate with us immediately. Great opportunities, lovely people ready to host, and lovely people ready to participate. So get your name on the list. Thank you.
Again, in that vein, we're also honoring people who are kind of nervous about being inside. Some of the dinners will be outside. So just let us know and make sure, because we want you to attend as many of you as possible. Another thing to put on your calendar, we love to have things put on your calendar. Monday, September 27th, the Youth Exchange Committee is actually hosting its first kind of reception and whatnot, looking for students who would want to be outbound in the coming year, a year from now, leaving in August of 2022. Obviously, you know, Youth Exchange has been in somewhat of a hiatus over these last 2 years, but we're pretty confident it'll be back. And so we're really looking for students who would be interested, at least in learning about it right now. And the more that are there, the more we'll have an opportunity to have a group of people to select from, a group of students. That'll again be on Monday, September 27th at 6:30 p.m. Just look on your, there's a thing that came out from the office on Youth Exchange. Check that out. You'll kind of see what's available. And even coming up, right after that, this fall is a busy time, Amy Mabe, who will be talking about Operation Harvest. And here comes Amy.
Thank you, President John. Okay, gang, I am here today to talk to you about everyone's favorite fall activity, Operation Harvest. On your table, if you haven't already seen this, this is the sign-up sheet for the different activities that we are looking for volunteers for. And several of these are super duper easy. They won't take very much time. Some of them take a little bit more time, but guess what? They're a lot more fun. So grab a pen, get the green sheet. You will see on the back the people who have already volunteered their time. Give them a round of applause. Come on. Thank you. And there are some people on here who I see in multiple categories. So that means they are doing more than one responsibility, which is awesome. So we want to encourage you all to take on one or more responsibility as well. This is, remember last year how awesome it was? Wasn't it great last year? So much fun and so fulfilling to see all that food out there at the fairgrounds getting turned in. So, you know, we have a similar situation this year where we can really make a difference to a lot of people. So this event doesn't take place without you all. So grab a pen, grab the paper, and sign up. I mean, you can even just donate money. We'll take your money. Come on now. So signs and holding a sign in your yard and all sorts of stuff. So Quinn is the chair. I'm the co-chair. You can ask us questions, or when Carolyn's back, get to her if you have questions about this. But of course, the two big things that we do need at least 100 volunteers for is the drop-off of the bags, the paper bags, and the pickup. Now, one thing that we really want to encourage is that you either sign up to do both. You drop off, and so you know where you dropped off the bag, and then you go back the next week and pick up at the same houses so that the route is a lot more efficient and effective because you know where you went and you're not guessing where somebody else went and dropped off a bag. So if you can either do both or grab a buddy and you do one and they do the other, or you do both together and then maybe go to lunch, I don't know, something fun. So definitely get your friends and your family and encourage them to help us out with this. Thanks.
Thank you, Amy. And I know one thing we learned last year is putting those bags out in advance makes a huge difference. So with that, keep that date in mind. And Austin Beebe will be up here. You've heard his name mentioned once already today, or twice, or always in a good way, but Sergeant at Arms.
Well, thanks for having me up here. I'm going to play a little bit of trivia. We're going to have some wise words of wisdom. Is that even how you say it? And just some interesting facts. So first question for everyone here. First of all, get your dollars out. I want to see that paper. Anybody know what national holiday is today? Anybody? No, it's National Teddy Bear Day. So I'm looking at people on Zoom right now. If any of you are sitting there at home in your onesies with your footy pajamas and your teddy bears, you're excluded. Everybody else pay $1. So speaking of bears, let's say you're up hiking at Mount Rainier and you see a black bear on the trail, you're with your friends. The black bear starts running at you. What do you do in that situation? Does anybody know? I think I heard it. Someone said run faster than your slowest friend. So if you are that slowest friend, you know who you are, pay $1. If you're not, congratulations, you live another day. Speaking of runs, who here participated in the downtown Yakima Mile? Anyone? I see one. Anybody else? Well, I guess everyone else has to pay $1 and give me a mile right now. Let's see it. Go out in the parking lot, start running laps. I was super impressed. The guys, or the fastest finisher for the guys was 3 minutes and 51 seconds for a mile. And for females was 4 minutes and 29 seconds. I don't know about you, but I can't get off my couch to the fridge and back in 4 minutes and 29 seconds. So I'm impressed. It also went to a great charity as well. So what a great organization. The one thing I love about our organization is we take money and then we donate it to our community. We do scholarships, we do projects. The downtown Yakima Mile, they just take your money and run. So I don't know. I do want to apologize a little bit for the scratchy voice. Obviously the smoke is just kind of hurting everyone right now. It's just terrible. The smoke outside's really toxic, so I recommend people stay inside. They get their exercise when you can. If you can't run your outdoor mile, do some laps around your island in the kitchen, do some push-ups, do some sit-ups. I think doctors will agree the best thing for your health is to make sure that you're active and eating healthy, right? So just make sure that you do that for your physical health. I do want to give a sincere thanks to all the firefighters and first-line responders. So if you do know a firefighter or you want to support firefighter, make sure you pay that $1. We want to give our sincere grats. I don't think anyone here in the room is one because they're all out helping out. So I just want to genuinely give some gratitude there. Another profession that I do want to be thankful for is our doctors in the room. I know we have a handful here and some that are speaking. So if you haven't spent half your life in college, please pay $1. You owe up. Trust me, it's not as expensive as their tuition. A couple interesting facts about doctors' medical conditions. Something that I didn't learn, or I didn't know, is if you grew up playing video games and you're a surgeon, you are 37% less likely to make an error during surgery and 27% faster than your non-gaming coworkers. So if you're a parent and you ever told your kids stop playing video games, that's never going to help you in career, you were wrong, pay $1. So the thing I learned last night, I was doing a little bit more research on weird medical conditions because I'm just strange like that and I like weird facts. There's a condition, and I'm going to butcher this, called hyperthymesia. And it's a condition where you can't ever forget anything. everything that you've seen, everything that you've heard, everything that you've experienced, you'll remember for the rest of your life in picture perfect detail. What was that? Yeah. Well, you know, unfortunately, I can't remember any of the rest of my facts. So without further ado, I do want to introduce Dr. Tom Boyd. He's going to introduce our speaker here, and just give a round of applause to all the doctors, all the firefighters, all the first responders. Thank you.
Good afternoon, everyone. It's my distinct pleasure to introduce Dr. Dave Maloney. Dr. Maloney is not only a colleague, but a friend, and importantly here, he's a native son of Yakima. Dr. Maloney actually graduated from Davis High School in 1973. His father, Fred Maloney, worked at Edwards Equipment as an engineer. Some of you are familiar with his work. Dave, following high school, went down to Stanford, worked at Stanford and obtained an MD and a PhD with a focus in cancer biology and immunotherapy of cancers. In 1994, he returned to the Northwest, where he joined Fred Hutchinson Cancer Research Center and the University of Washington, where he continued work in immunotherapy for cancer. He had a lot to do with a drug called Rotux, which was developed to treat certain kinds of lymphomas, and probably well over 1,000 people in the county have likely received treatment with this drug. It plays a major role in the treatment of hematologic malignancies called lymphomas. Dave had much of his focus in Seattle in the heme malignancies, specifically things like lymphoma, leukemia, multiple myeloma, and he continues that work today. His recent focus has been that of CAR T therapy. This is one of the more cutting-edge therapies where T cells from your body are taken out, engineered, and trained to attack cancer that is the focus for your particular care. Dave currently is the head of the CAR T program at the Bezos Cancer Center in Seattle. He focuses much of his work on a very selected group of hematologic malignancies that are treated in this manner, but this may become a tool that's generalizable to many other types of cancers. Dave has over 250 publications, and not to chew into his time, I wanted to go ahead and introduce Dave today and hopefully enlighten people as to some of the newer breakthroughs that are occurring in cancer care.
Thanks very much, Tom. Let me see if I can share my screen here. Okay, are people able to see this? Okay, what I'd like to do is to talk to you about how we can use your immune system to tackle cancer. So this is what is known as immunotherapy. Now, I'd like to break my talk up into this outline. First, what is the immune system? And then what are some of the components of the immune system that we can actually use to fight cancer? And that includes monoclonal antibodies, drug conjugated antibodies, something called bispecific antibodies, something called checkpoint inhibitor antibodies, and then lastly, what Dr. Boyd was mentioning, cellular therapy with CAR T cells. Now, what are the current pillars of cancer therapy? They certainly used to be the top three here: surgery, radiation therapy, and traditional chemotherapy. And these they still have their place, but they're largely being displaced by the bottom two things here: targeted therapy and immunotherapy. So surgery can be very definitive, but it can't treat disease that is spread. Radiation is the same story. It can treat more difficult to treat areas, but again, only for localized disease. Traditional chemotherapy usually has toxicity to the bone marrow. And then the newer treatments, targeted therapies, are actually aimed at mistakes that the cancer has made that makes it vulnerable. So it's actually targeting specific molecules in the tumor that are helping it survive. And these treatments often have much greater tumor specificity and thus have less generalized toxicity. Now, immunotherapy is also tumor targeted, But these treatments really are thought to involve components of the immune system, and that's what I'm going to focus on today. So there's two key parts of the immune system. There's the cells are the T cells, and T cells are cells that are patrolling in your body. They kill virus-infected cells, and in some situations, they can actually kill cancer cells. And they're part of our response to vaccines. So when you get a vaccine, your T cells learn about that, and then if you then get that bug, then your T cells are ready to go and can eliminate it. Now, your other component is the B cells, and the B cells make antibodies against bacteria, viruses, or other pathogens, and they also can respond to vaccines by making these antibodies. And normally, a large component of the proteins in your blood are actually made of antibodies against a variety of pathogens that you've encountered over your lifetime. So how can we use this to potentially treat cancer? Well, the first thing I want to talk about is the use of antibodies. Antibodies are these guided missiles of the immune system. They're actually proteins. They're made by B cells, those cells that make antibodies, and they're produced in quantity by a cell called a plasma cell, which are basically antibody factories. Now, when you get exposed to something, it takes 1 to 2 weeks to make an antibody to a new pathogen. Every B cell you have is essentially different, and its progeny only makes one type of antibody. And we have billions of B cells making essentially billions of different antibodies. And this is what provides, again, immunologic memory, and again, why we get vaccinations. So monoclonal antibodies are antibodies essentially from one B cell that can be made in the laboratory, and then they can be made to whatever target a B cell could respond to. But they're all identical, and essentially they can be grown and harvested and put into a bottle and essentially given to a patient for cancer therapy. It's not alive, it's just a protein, but it's essentially like a guided missile that can bind to the tumor cells and help destroy them. So can we use these antibodies to treat cancer? And the answer is yes. And you heard from Dr. Boyd that rituximab is one of the first antibodies approved to treat cancer. This over here, this green shape, is what a monoclonal antibody looks like. And you can think of it as having two tips shown out here that can bind to a target on the tumor cell. And it's very specific for this target. It won't bind anything else. And so these proteins are floating in your blood. And if they encounter a cell that has the target, they can actually stick to that target. And when they bind, that can then aid in the destruction of that cell or actually kill it. And in lymphoma, we found back in the late 80s and early 90s that when we gave people these antibodies, we simply infused them, that in some cases their lymphomas would go away. And this led to the approval by the FDA of this antibody called rituximab for the first antibody therapy approved for cancer. And that was back in 1997. And this is still widely used in nearly every patient with lymphoma. And it's also used in autoimmune diseases, and there's all kinds of other uses that have emerged. Now, this was actually a review I wrote back in 2012 for the New England Journal of Medicine, trying to explain how does rituximab work. And the antibody, when it binds to the tumor cells, can actually directly kill it in some cases. It can actually poke holes in the cell, which leads to the cell's death, or it can actually encourage other cells to come and help kill the cells by its binding. Well, what about actually, though, in the clinic? Back in around 1998, after rituximab was approved, the French group did a study in over 1,000 people with aggressive lymphoma, and they were treated with the standard of care, which was a CHOP chemotherapy. And this is the name of the drugs used in this chemotherapy. And this treatment could cure about 47% of patients at 4 years. Now, the experimental group was then randomized to get CHOP, which was the same treatment as the other group, but in addition got the simple infusion of this antibody each treatment with the chemotherapy. And you can see, to actually everyone's surprise, the outcome was better by adding this monoclonal antibody rituximab to the chemotherapy. And you can see there's about a 12% improvement in survival. And this paper was published in around 2000. And the day after this was published, essentially nobody was treated with CHOP anymore. And the new standard is rituximab plus CHOP. And it's actually still the standard today. We've been having trouble beating this, but this is an example of how adding an antibody or immunotherapy to conventional chemotherapy can improve the outcome. Now, we have antibodies now approved for almost every single type of cancer out there. Rituxan or rituximab for B-cell lymphomas and leukemia. Here's one for multiple myeloma. Daratumumab, trastuzumab is one for breast cancer. Cetuximab in many kinds of other solid cancers. And bevacizumab or Avastin for colon cancer. And this is just the tip of the iceberg. I think there's 30 antibodies approved now for cancers. So almost any type of cancer now usually includes an antibody added to the treatment to try to control the disease. Well, antibodies themselves are impressive and they do improve things, but they're not curing everybody. And so can we use antibodies to do additional things? Well, one of the things we can do is we can use these antibodies to actually carry a drug or a toxin to the tumor cells. Remember, these antibodies are like guided missiles, and they'll only stick to the tumor cells. And so you can now get a drug that will now only go and bind to the tumor. So this makes the drug or toxin more specific to the tumor cells than the rest of the normal tissue, and this decreases the toxicity. So here's a list of 5 different drug-targeted antibodies in just the lymphoma space. And so this can either carry, in this case, it's carrying a radioactive molecule, so the radiation is delivered to the tumor, or it can carry these toxins to go to the tumor. And these treatments have been quite impressive, but they tend to be slightly more toxic than the naked antibody, and that's because they now carry a toxin, which can have some side effects. But how do they work? Well, this is an example. This is a picture of an antibody with these moieties attached to it. So these are essentially the drugs or the toxin that binds to the tumor cell target. The tumor cell then engulfs this into what's called a lysosome, and it goes into this lysosome. The toxins come off, and then the toxins damage the DNA of the tumor cell and result in the cell's death. So this becomes a targeted therapy. It's more specific than just a chemotherapy drug because it's being targeted to the tumor cell by a component of the immune system, which is now a monoclonal antibody with a drug attached to it. Well, do these work? Yeah, so here's an example of a drug conjugated antibody versus the standard of care chemotherapy for patients with lymphoma. Lymphoblastic leukemia. So how do you look at these curves? These curves are unfortunately survival curves of patients with this very aggressive type of leukemia. And you can see with standard therapy, 50% of the patients have already died within a couple of months in this setting. So these are advanced leukemia patients. And you can see that if they get the antibody instead of the conventional chemotherapy, they had a better outcome. Now, unfortunately, it's not curing everybody, but there is a sizable fraction of people who are doing better, and their life is clearly prolonged by this new kind of treatment. So this is another advance in the field. Now, these advances are not usually all or nothing. We're not curing everybody with an advance, but it's incremental improvements, and that's how we make progress in the treatment of cancer. Now, I want to spend a second talking about bispecific antibodies. Now, these are a little bit of a difficult concept to explain, but this is an example of an antibody shown here and another antibody shown here. So this antibody happens to bind to something called CD19, and CD19 is often on tumor cells. This antibody binds to CD3. Well, CD3 is actually on T cells, and T cells are kind of the killer cells of your immune system, and they're good at killing cells that CD3, cells that have CD3 or T cells. So what investigators did was they essentially chopped off this part of an antibody and then linked it to this chopped off part from this antibody. So now you have kind of a zipper. You have a fragment that can bind to CD19, and the other side can bind to CD3. So what does that get you? Well, that gets you essentially a zipper that can stick the CD3 cells, which are the T cells, to the leukemia or lymphoma cells, which are the CD19 positive cells. So now this molecule comes around and it zippers the cytotoxic T cell up against the lymphoma cell, which actually turns on this T cell. It activates this T cell's killing mechanism, which then results in killing the leukemia cells. So very sophisticated way of now redirecting the T cells to potentially kill the leukemia or lymphoma cell. And there's a lot of interest in these types of antibodies right now, and we're going to have 4 or 5 more approved in the near future. Now, this is an example of a bispecific antibody compared with chemotherapy in patients, again, with leukemia. And this was published in the New England Journal in 2017 and led to the approval of this bispecific antibody, this zipper molecule, essentially, called blinatumomab. And this was then FDA approved and now is standard of care in many cases of this type of leukemia. Now, this is something you've all heard about. Maybe you haven't been aware of, but you all heard about it, and that's because the drug companies are advertising this all the time on TV. This is examples where the TV says live longer with lung cancer or breast cancer, and it's because of these things called checkpoint inhibitor antibodies. And in fact, this is such an exciting area that the Nobel Prize in Medicine went in 2018 for the discoverers of this system. So this requires a bit of explaining. So this is a tumor cell shown here, and this is a T cell. Now, T cells are often trying to kill tumor cells, but tumor cells are really smart, and they realize that T cells have a system that can shut them down. And this is important because you don't want all of your T cells just wildly attacking your tissues. They have to be somewhat controlled. And one of the ways they're controlled is by expressing a molecule called PD-1. Well, the tumor cells have learned that if they put out the opposite part of PD-1, the thing that can bind to PD-1, this is called PD-L1, it tells the T cell, don't kill me. So this T cell comes around and it's trying to kill the tumor cell, and the tumor cell says, hey, don't kill me. And the T cell says, okay, and leaves. So essentially the T cell is turned off by the tumor cell expressing this molecule. So what Dr. Allison and other colleagues figured out was, well, if you block this signal, so you can make an antibody that binds to PD-1 or an antibody that binds to PD-L1, and that interferes with this signaling. And then what happens is the T cell then doesn't get the signal, don't kill me, and it then results in killing the tumor. So it's kind of it's blocking a negative repressor of the T cells. So kind of complicated, but it's very exciting. So this has then led to the approval of dozens of checkpoint inhibitor antibodies against several pathways, and they're approved now for almost every type of cancer. And these are, again, called checkpoint inhibitor antibodies. And this is one example of checkpoint inhibitor antibodies compared to chemotherapy in patients with advanced lung cancer. And this shows not much change in the first year, a slight improvement in survival. But then when you get out to 2 to 3 years, there's a major advantage of getting immunotherapy compared to chemotherapy. And this has largely changed how we treat many types of lung cancer and many types of cancers now. Very exciting times. So lastly, I want to talk about T cells. What's so special about T cells? They can kill these virally infected cancer cells, and they can also kill tumor cells, but they're hard to find. So how does this work? Well, the T cell is only going to kill if it has a specific interaction with the cell bearing the target, which is called the antigen. And the way this is thought of is that here's the T cell, it has a receptor, it sees an abnormal cell, it gets activated, it kills the abnormal cell. But if it sees a normal cell, it's not activated, and then it just goes around looking for another tumor cell. So we have billions of T cells in our bodies. Each one has this own lock and key. So the system is incredibly specific and sensitive. So how can we exploit this? Well, one way is we can try to find these T cells that are killing tumor cells. And you can do that by isolating T cells that come from a tumor, because maybe they're in there trying to kill the tumor. We can expand them and give them back. This is called TIL therapy, and actually can treat some kinds of lymphoma, some kinds of skin cancer called melanoma. But this is looking for a needle in a haystack, and it's very hard and complicated. So the alternative way is to genetically modify all of the normal T cells to either introduce a receptor called the T cell receptor, or CAR gene, chimeric antigen receptor gene. And this can be done in 2 weeks, where we now take T cells and make them specific for whatever we want to. So this has led to this process called CAR T cell therapy. And the way it actually works is you have your blood run through a machine called an apheresis machine, and then back in your vein, we take off and isolate the T cells. Those T cells are then genetically engineered using usually a retrovirus or lentivirus, which then makes those cells have a receptor specific for whatever we're trying to grow or whatever we're trying to attack. And so these cells are then grown up in large numbers and given back to the patient. And this is called CAR T cell therapy. And it's one of the major advances in cancer research in the last 5 years. Now, this is a living drug. And this is an example of just measuring how many CAR T cells are in someone's blood after they were infused. Once they're infused, the cells home, they signal, they bind to the tumor cells, they secrete cytokines, which can make people quite sick, actually. We can detect these cells in the blood, and they peak around day 7 to 10 and then die away. And as you can see, go here. And this results in putting patients into having their tumor go away in a matter of days to weeks, and if we're lucky, and patients can go into remission. And then these T cells can probably hang around and do some surveillance for some time afterwards. So here's an example I'd like to leave you with. This is a 61-year-old man, had a very high-grade aggressive lymphoma. This was unresponsive to all therapy. He had chemotherapy for 6 months and chemotherapy, a different chemo for 2 months, was essentially dying of his disease. Came to the Fred Hutch in January of 2018. We got him CAR T cells manufactured by the end of February, barely. And he got the CAR T cells, did very well with it. And this is a PET scan beforehand. All of this hot stuff, this bright area, is tumor. He had a large, huge, very huge abdominal mass, and it's completely gone 1 month after CAR T cells. And he remains in complete remission, probably cured of his disease, now 3.5 years after therapy, where he would have had weeks to live when we first saw him. So, so this is an update of one of the trials that got CAR T cells approved for patients with a lymphoma like this. And you can see that we can cure about half of the patients, even though their expected survival would have been less than 3 or 4 months. So this is very exciting. We now have 3 CAR T cells approved, and this is radically changing how we're treating patients with those types of lymphoma and hematologic malignancies. So cancer therapy is changing rapidly. There's an increasing use of precision medicine where we have targeted drugs. There's an emergence of these targeted drugs and antibodies that are increasing tumor specificity and decreasing toxicity. The cellular immunotherapy is exploding. We have lymphoma, leukemia, and myeloma. CAR T cells approved so far. We have many trials ongoing right now in lung cancer, breast cancer, and other cancers. So the future is very bright for the development of novel treatments. And so this, I'll leave you with, this is a picture of the Bezos Family Immunotherapy Clinic at the Saddle Cancer Care Alliance in the Fred Hutch. And this is a clinic dedicated just to giving T cell therapies for patients. So I'm going to stop there, and I will hopefully have some time for questions.
If you have any questions, if you just speak them and I can either relay them or I think maybe he can hear them. For those of you on Zoom, I think you may have to do them in chat. I'm not sure. But questions? Charlie?
To what extent are these therapies available outside of the Red Hutch system and outside of the
Sorry, I can't hear the question, so you'll need to repeat it. If
To what extent are these therapies available outside of the Fred Hutch and Seattle area?
Yeah, that's a great question. So the majority of these therapies are available in almost any oncologist office. The exception are the T cell therapies, the last thing I talked about, the CAR T cells, that requires treatment at a very specialized center. And essentially, we're one of the only places in the Northwest that can give CAR T cells for patients with lymphoma. And it's a big process. You have to be in Seattle for 2 to 3 months to be able to get that kind of treatment. So it's very complicated, but we're trying to make it easier and potentially get it out to community centers in the future. Good question.
Others? Corey? Gene silencing, he's asking about. And what's the name of the gene? Calipage gene?
I don't think I know that gene, but I can generally, in gene silencing, that's getting a little more tricky. So when you're talking about gene silencing, you have to go and figure out what the problem is with the cancer and then try to correct that gene. And so it becomes an issue of how do you affect all the cancer cells and turn off a gene? And that hasn't been really successful yet. But there is technology that can potentially do it, but it does have some ethical issues in terms of manipulating the genes in a patient, which is just challenging.
Thank you. Any other questions? If not, this has been really, really exciting. And oh, wait a minute, Becky. What's the difference between Hodgkin's and non-Hodgkin's lymphoma?
That's a great question. Hodgkin's disease is named after a gentleman, Thomas Hodgkins, who discovered this. It's typically a disease in young adolescents and young adults. Also, there's a peak in elderly patients as well. It's just a different type of lymphoma. It does tend to be more curable than our other types of lymphoma in some cases, but it's just a separate, the cell is slightly different from what it came from than the other typical lymphomas. That's the easiest way to explain
it. Thank you. Anyone else? If not, it's wonderful to hear what's happening, because it used to be such a dreaded thought, and now the fact that there's hope is wonderful. Thank you very much, Dr. Maloney.
Yeah, thank you very much.
In your name, Dr. Maloney will be giving a book to one of the community centers here. This is a teen book. It has to do with a young woman in Pakistan who is really struggling to overcome a lot of obstacles and perhaps go into teaching, wants to go into teaching and into research and doing something perhaps like what you're doing. So again, thank you very much. We appreciate it. Next week, our speaker is W.D. Frank, who some of you know. He will be speaking. His topic is on a new book that he's working on and is in the publication stage. It's called Of Women, Men, and Mountains, Kay Kershaw, Isabel Lynn, and the Double K Mountain Ranch. This is a really interesting topic historically and connects with William O. Douglas and one of the and the history of this area. So he's been working on this for quite a while, and I think it should be really a fascinating program. The following week, Peter Arnold from the museum is going to speak about some of the changes and some of the exciting things happening there. Unfortunately, I have to tell you that Peter is right now hospitalized. He is suffering from COVID, as we know. He is doing very well at this moment, but we'll just have to wait and see. But we wish him the best and hope that all will be well. And before we go, I think I should tell you that September is usually a big month in the Yakima Valley. We all know about the fair, which we're coming up. 100 years ago, they were advertising for the fair for weeks ahead of time, where one of the big attractions was to be the new sport of, if you could imagine, auto polo, playing polo from a car. So if you want to get into that, I'm sure we can figure that out. The other thing is you also could have gone to the movie. The movies were either Salvation Nell, which is the story of a girl who made a god of a man, which I don't know how hard that would be, but whatever. And The False Road, a story of underworld love made clean. Now, there you go. It was also the time of fall fashions being announced. Once upon a time here in Yakima, and I think across the country, there would be a day in which all the department stores, all the fashion stores would unveil their windows with all the new fashions for, in this case, the fall. They would also do it in the spring. And one of the big things, though, with big controversies that was happening in 1921 was whether, in fact, you should continue to have female employees who bobbed their hair. This was quite controversial because there were some businesses, and particularly in Chicago, who had announced that any female employee who showed up at work with bobbed hair would lose their position that day. The head of the YWCA here in Yakima said that the reason for this was not about the hair at all, even though long hair is obviously much more attractive than bobbed hair for women, but it's the extreme type of dress that accompanies it, particularly rouge and immodestly thin clothes of abbreviated lines. So keep that in mind, and you will be happy to know that that's what happens today. And with that, we are adjourned.